How we control our activities, including climate activities, through this semiotic theory. And what is it? In this approach, many factors, it's not a whole some something like human being who has fear and can operate with you. Not to be prepared is with how we operate with now. The factor of our operation is now. It's senseless situation. Who did this? It was by computer, so in some words. But in the case of accelerated with science and other needs, we need some cognitive software. Some men who or some enemy who has grades and care use this approach. And from this point of view, it's natural to have division distinction between system, intellectual systems, semantics, system in relation to the world, now, subject who operates with science, who can correlate science with needs, with work, construct some things. And this comes with a chance. This approach this more simple is based on ideas of class future. The great American philosopher, as it was written by Roman Epictetus, was developed for heading some places in American universities. Outside of the university, he worked as and now he is a philosopher of the USA, and maybe in the beautiful time. In the version of information and seniorities, they are quite big, and I think it's quite selection. So we have in this education, we have not place, we have not room for cognitive something. From this point of view, we can see that he introduced very interesting notion of quasi-mind, which he correlates with sign itself. Sign is itself a quasi-mind. So from this point of view, I think that to make a change your idea about most of the several researchers, because we teach ourselves, we have some wire computers to regulate the operation of information, and they based on 4 elements, 4 nucleotides, and we can be a very next some binary units because they have the features number of bonds. So the digitalization of the our cellular mechanism and actually the minimum of all this wiring system consisted of these 4 elements, 4 nucleotides. So it's really possible. And in my presentation, I would like to show that it is possible to have alternative version of semiosis, which doesn't include imply the subject. For the subject of the brain, we can see that science itself are responsible for operation with science and reason. And now the artificial intelligence from one side and biosemiotics demonstrate the possibility of this version of which remains only in manuscript. There was no place in academic publications, and all this idea remains in records and handwritten papers of Charles Peirce, and were published only recently. First of all, you can see the basic definition of science and what is the important for Charles Peirce, that there is no reference to the human thought, because we can have 3 parts. A, sign is something, A which means something. B, it's interpreted sign, the term of created by E, into the same sort of correspondence with something C. object. So each sign consisted from three part relations between A, B, C, or interpreted object and sign itself. For example, my name is Suren, that is a sign. It is an object, it's me, and some relation between me and my name. So these three-part relations, which do not presuppose this from any cognizant element. From this point of view, in this note, we introduce very interesting notion, quasi-mind. What is the quasi-mind? Something which can behave itself as a sign. And this is a sign itself. Every sign, even if external to all mind, must be a determination of a quasi-mind, external to all of minds. Like, for example, our devices or ourselves. The next idea, what is very important, we can see that in semiotic properties, you find the same relation that in our human communication, but without non-difference. And from this point of view, you need utterer and the interpreter. At this moment, I am the utterer, and you are the interpreters. Of course, if we have cognitive subject and we do it through our brain. But what happens in our brains? What happens in your brains when you hear me and you, through after proceeding of this virus, have some linguistic pattern, some semantic pattern. So we can see that the approach is very general. He spoke even about weather. Weather can give us some signs and line signs. What is interesting, because one of the characteristics of sign is that it's something through it we can fly. Okay. So I skip some very interesting ideas. And so the new version of Charles Peirce-Seniorlis, he thought on it to have different quasi-minds, not only one quasi-mind, but quasi-utterer, quasi-interpreter, and some relation between them. So for him, he came to the three-part communication, and each sign implies three components, which are in operation and who are in communication with each other. First of all, that is sign thought. Sign thought that's saying to us something, and after it, the sign which is interpreted. So we can see each sign can be represented as three-part relation and three objects. And that is the full idea, how it is possible, and the meaning of the moulded sign. So actually, every sign consists from different parts of meaning, and they came to communication of each other. Of course, it has to be understood, and you need to read. Maybe you can see it in proceedings. So let me go to the very interesting idea about sign finish, because every sign refers to the other sign when they finish. Finish is when this meaning is constructed and the communication is terminated. I would like to make a quotation from Habermas, one very important figure in philosophy of 20th centuries. He spoke of quasi-mind because he wanted to conceptualize the interpretation of sign abstractly. Takes from the model of linguistic communication between a speaker and a hearer. He takes even from the basis of the human brain. Today, this makes us think of the operation of artificial intelligence, of the mode and function of genetic code. we can see that at 70s, Habermas was forecasting development, but most of semiotics and biosemiotics and biologists and philosophers are against this idea of bottom line. And the objective is a semi-scientific and or even non-scientific, etc. So till now, but it was very important that in biosemiotics and biology, some support came from biology. And one of the prominent philosophers, that the quotation from teaching, because there was a complexity of brain, despite reflecting advances in neuroscience, it may still be permitted to speculate about the real implementation of mental stimulus. On the other hand, there are reasons to be more hopeful that insights into the physical implementation of interpretation might be obtained into molecular biology. So it's very interesting when you see complex control system, you need some semiotic control system of it. And the semiosis without coping the subject is inevitable. So thank you very much for this opportunity to present. Yes, and you can see that some development of this can be seen and even more complex how communicates with each other in general information. And I'm very proud that my paper will come to biology from all this beautiful paper. Biology, let's say, this for you, we have to identify a single information, not with some agent, but with its system itself. Thank you for your attention.
Thank you very much. Well, I have a question. When we talking about quasi-mind, really correlates with one that you in artificial intelligence we talked about. I know linguistics is a more ancient development in people psychology, linguistics, and so, and we are glad we're writing some ideas. So, is there some more tangible definition of?
Yeah, this is a definition of first who didn't publish it, and it's really this. He wrote to his girlfriend of very well that he might publish his ideas because he is afraid of the relation of the academic society. Because academic society, maybe it's quasi-scientific, so he all this not about quasi-science, but he wrote only what it's
But
and even not in these non-published paper issues, like publication.
But this you know about links between biological links, communication, and this idea was much earlier in the research, but was with the link alterations between these two.
Yes, of course, but we can people request for example, identification for some papers, which are again this idea. And they spoke about proto-semiosis, spoke about what mind, spoke about proto-semiosis before they wanted to allow semiosis some non-cognitive subject. Therefore, it is interesting what this.
Students, there is one more I just recently. Communication supports two responses. Okay?
Yes.
But communication between the entire
Yes.
and it passed with information to RNA actually created clone. Then the RNA is a clone of RNA. RNA is clone of RNA. And after RNA passing for creating next cell, that is cloning. Here the question is this communication between creating clones and communication between respondents. Are they the same or no?
No. The protocol made replication of but the main thing is after when you have a replica of the data and it takes to the element of the two because you acids in this way. That is the main problem. And we have very sophisticated system of control and at the same time phase. So you can see some and complete. And that is the answer given completely, excluding the. There's no mistake. Yes, what is different outcome reported. You can make mistakes, so in the outcome reports, you have something like cognition. Without brain, but some not cognition.
Interesting.
Yes, quasi mind.
Yeah, unfortunately, I find it short, so thank you all for. How, we know we have a respondent or reporter which then will address us by Zoom. Can we try to contact the audience? Okay. So for very important note, who are the reporters? Okay, be closer to microphone. Be closer to microphone. This is one of the mistakes for my mistake. No, about it was multiplied. So the next one is to correct it. We have to close the microphone because some our
As you already mentioned, there could exist a God which created us. And therefore, there is a question, could we be the ones which are going to create new creatures like AI or AGI, which is now existing?
very, very important question in the sense. If you interested for the detail.
Good afternoon, can you hear me? Can you hear me now?
Yes, thank you very much. We're greeting you from Samara. Are you in
Yes.
Samara? So, привет, hello, Samara. Please start your presentation. You know, there's 15 minutes all over. Take 10 minutes or how much you like and leave a little bit for questions. Please start.
Okay. Good afternoon. The topic of the work that I, Tissen and Maxim have done under the guidance of Parin Rostam is feature selection based on MRMR, maximum relevance minimum redundancy algorithm, and genetic algorithm for data classification problems. In this work, we will explore a new feature selection algorithm based on MRMR and the genetic algorithm. But first, let's define.
Excuse me. Please say a little bit, slower, because the words when come, they intersect with one that you say after. Okay. So
okay, sorry.
Our listening. Thank you.
But first, let's define why feature selection is necessary. Okay, in practice, feature selection is used, for example, to detect unauthorized access in a computer system or network. An intrusion detection system collects and analyzes information from different areas of network to identify potential security threats, both external and internal to the organization. Dealing with a large volume of data that contains various irrelevant and redundant features leads to increased processing time and low intrusion detection speed. Feature selection is applied as a preprocessing method to reduce dimensionality by removing redundant and irrelevant features. There are lots of algorithms available that help determine the best subset of features. However, this task of selecting this optimal subset is NP-complete, meaning that a guaranteed optimal solution can only be found through brute force search, which can be time-consuming with a large number of features. Existing feature selection algorithms may not always achieve a sufficiently high classification quality. That's why proposed feature selection algorithm was created and further described. The slide presents the mathematical formulation of the feature selection problem. I will briefly explain that the feature selection problem can be formulated as the search for the optimal subset of features, denoted there as X prime, which contains only the most informative features from the original set X to achieve maximum accuracy in classification. The objective function f of x prime can be chosen according to the specific task and the feature selection method being used. In this study, the goal is to maximize the weighted F1 score. It's worth noting that the proposed algorithm is based on a genetic algorithm, where the probability of adding a feature from the parent to the offspring is determined by the formula of minimum redundancy maximum relevance algorithm, as shown on the slide on the right top part of this slide. For the initial feature estimation, which is used to compute the probability of adding a feature during mutation from the set of features not present in the parents, a selection algorithm, a select k-best algorithm and information gain formula were used. The figure visually demonstrates that a parent with higher classification quality is more likely to become a parent. Similarly, the selection of features from parents to offspring favors the inclusion of features that perform better on the maximum relevance minimum redundancy algorithm. The detailed block diagram of the algorithm is shown in the figure. Now let me describe the main features. In the first step, a population is created consisting of different feature sets. The size of the population is equal to the number of features. It has been shown that this number is optimal. The features for individuals in the initial population are randomly selected. Before crossover and creating offspring, mutation occurs by adding features that are not present in the parents. The number of added features depends on the number of common features in each of the two parents, as well as the weighted F1 score value for each parent. Then features are added from the parents to the offspring, and the probability of addition is calculated on the maximum relevance minimum redundancy algorithm explained before on the offspring. So the algorithm has been described. Now let's see which data sets we used for comparison. We've used three different data sets. The dataset D broken machine contains accumulated data about production equipment. It includes readings from 58 indicators. This dataset can be used to create a classification model for predicting machine failures. Additionally, it can help identify the indicators that have the greatest impact. The wine dataset consists of data resulting from chemical analysis of wines grown in the same region of Italy using 3 different grape varieties. 13 different measurements were conducted for these varieties. This dataset can be used to create a model that classifies wine varieties, enabling multi-class classification as there are 3 classes in the dataset. In the breast cancer dataset, the features are calculated based on digital image obtained through needle aspiration of a breast tumor. They describe the characteristics of cell nuclei present in the image. This dataset can be used to solve the binary classification problem of distinguishing between benign and malignant tumors. The number of observations of each class was analyzed, and as shown in this slide, there is a significant imbalance in the number of observations between different classes in each dataset. And to equalize the number of these observations, oversampling was used in the wine dataset and breast cancer dataset. This method involves randomly selecting observations from the minority class and adding them to increase the number of observations in each of minority classes. And undersampling was used in the broken machine dataset, which involves randomly removing excess observations from the classes to decrease the number of observations. Finally, let's move on to the results obtained from comparing these datasets. The results of the algorithm were compared with the results of the algorithm for selecting top K features and random forest algorithm on these 3 datasets mentioned before, as well as the classifiers based on random forest and logistic regression. As a result, it was found that when we use a random forest classifier for the proposed algorithm, the weighted F1 score in classification is generally higher compared to using the algorithms select K-best and random forest from scikit-learn library. The slide displays the exact results obtained using different feature selection methods for different datasets. The main results obtained during the research are shown on the slide. By employing the described algorithm along with appropriate classifiers, improved data classification accuracy can be increased compared to using univariate feature selection, or we use the select K-best algorithm, and random forest algorithms available in the scikit-learn library. This approach can be applied to preprocessed datasets from diverse industries. It's worth noting that the proposed algorithm will be used in remote sensing of the Earth task. The described algorithm was implemented as a software package, and it uses a programming interface corresponding to the scikit-learn library. That's why it can also be easily used by anyone for data preprocessing. That's all. Thank you.
Please, no questions. Okay, I have a question. You said that you compared your algorithm with other one, known one. And actually your advantage was just point or 15. Yes, I'm right. How tangible is this advantage? Yeah, I restrain to estimate, but on the first glance, it seems very small. Is it really because there may be incorrectness of experiments and so this age of its advantage and being equal or even disadvantage can be questioned. Can you argue this figure?
Yes, you're right, but it's worth noting that I use a genetic algorithm and I'm evaluating using the classifiers that were done for me, the quality of every individual. And if I will have a better classification algorithm, for example, for now, the best as it's as it's known, the best classification algorithm is the gradient boosting. I think the gap between my algorithm and existing ones, from this research will be more if I will use a better classification algorithm.
That is an average in different or many different experiments or estimates, but there were more tangible figures, yeah, than the one you mentioned. Am I right? So do you have other figures where your advantage is more, say, tangible? Yes, am I right or I'm not? You had this figure, yes, comparing with previous ones. As I understand you have other experiments where this advantage was much more. Am I right?
No, it's just yes about the because it has it's a logical guess because when I use genetic algorithm, I evaluate my individuals using the classifier that was that I get as a hyperparameter. And if I'll have a better classifier, I will evaluate my individuals or subsets of features better, and it will allow us to get better subsets of features from the whole population.
Okay, okay. Other questions? No. You have a question? No. No questions. Thank you very much. Okay. Okay. Passing to the next presentation. What will be our guest? So you are Razi. So
No, I'm here on behalf of my co-author's presentation, Mohammed al-Bakri, if I'm right. Yes. The article changed. This article was removed, and the article here is replaced with that one.
oh, that's news for me.
Yes.
Unfortunately, but which one are you looking for?
The one. This one.
This one.
Yes. Yes. And I'm not the author.
Classification and evolution of content available the time.
Yes.
Okay, so let me inform you that the title and presenter changed. Yeah, unfortunately, you in the last comment, but the now actually she will that is entitled Classification and Evaluation of Image Content Aware Targeting. Okay. And there will be Sohail there. You are Sohail. Ah, you are not there. Ah, you just are presenting the work. But can we know your name too?
Yes, my name is Navani Shapur.
Okay.
Represent my own activity. I asked for a visual presentation of the organization that a physical presentation.
Uh-huh.
So I presented on behalf of.
Good. Okay. So we're listening, but no, you have to know our time is short,
Yes.
10 minutes.
Yes. Hello, it is a pleasure to be here. I'm here to represent the paper titled as OICR, a classification and evaluation of image context error retargeting techniques. The authors are Mohammad Reza Keyvanpour, Sohaila Mehmollahi, and Aysel Saleh. The presentation this consists of image context error retargeting, the proposed framework for categorizing and classificationing, proposed functional measures, experimental results, and conclusion and future work. We start with problem definition, main goals, and then general function. Problem definition: assuming an image as an input of I with a size of n multiplied by n, the goal of image context error retargeting is to have another image, a new image I indexed with a new size of n multiplied by n that will represent the input image as well as it can, but with a resized version. The main goal is to preserving the important components of an image while resizing it as well, reducing the visual distortions in the resized image and preserving the important structures of the image. The general functionality of image context error retargeting is that we have an input image, we have a saliency map calculation, a desired output size for another TV show or anything with another resolution. Then we have a restriction. This part is optional. We may have or not have it. Then we will do a retargeting operation, having an output image resized based on context. Since the development of different televisions, computers, and all of that, a lot of context aware techniques have been provided, but the evaluation and comparison between them are not good enough. So we have proposed a framework containing of classifying techniques, evaluation measures, and analytical evaluations to compare other techniques proposed. The proposed framework classifying image context aware retargeting technique consists of three classes. The first class is discrete inserting or removing. This class itself contains of cropping-based techniques, sim curving-based techniques, and patch-based techniques. Form changing mesh technique, which is a single class containing of wrap techniques continuously, and a similarity measure-based techniques using multiple operator-based techniques to do retargeting. In our framework, we propose some measures to do the comparison. Opinion, which is the general idea in the proposed technique for doing the retargeting, the advantage of the and the strengths and benefits of the technique, and drawbacks of the technique that are the disadvantages in the proposed technique, accuracy that is in three values: high, medium, and low, and the computational cost that is the total cost of applying the technique to the image, which is itself of three types of high, medium, and low. We then applied our framework into some of the most recent related studies, as you can see in the picture. For the first technique, there are cropping-based, sim curving-based, and patching. In cropping-based, there are some optimal visual windows using for cropping the image based on the importance of the context that we're cropping. In steam-based carving, there are some steam hypogeneous bidirectional functionals inserted or discreted from the image so that we have a targeted image. In patch-based techniques, one simple image will be considered as multiple small patches. The patches will be rearranged, and then the new retargeted image will be generated. Cropping base itself has the opinion of conventional cropping. Steam-based have main steam cropping corrected and indirected. Patch-based are bidirectional or transition. The advantage of cropping base is keeping the main structure of the image and having the final image without any distortion, while its drawback is inefficiency for images that include more than one important component. So they use the cropping based on the components choosing the window. In the steam curving base, the advantage is keeping the local structure of the image and no restarting reports of the image are removed, while the drawback is inability in keeping the main structure of the image and inefficiency for considering the image components. In patch-based, keeping general structure of the image is one of the advantages. Existence of the least directions of the final image is one of another advantages. Its drawback is within an image is that its inability in keeping the local structure of the image and high computational cost. In wrapping-based techniques, distortion distribution based on the different directions of the image are implemented, keeping the main structure of the image while it has an inability in keeping relative portions of the components connected. In multi-operator varies, existence of the last insertion in the final image and using the appropriate aspect of each of the operators are some of the advantages, while the drawback is inability to overcome the detect of the operators. In general, we can say that cropping-based techniques has accuracy of law and the computational cost of law. If we care about the computational cost and we have a problem with the resources we are using, this technique can be used. In seam curving-based techniques, accuracy is high, while computational cost is medium. In patch-based technique, accuracy is medium and the computational cost is high. In wrapping-based, accuracy is medium, computational cost is high, and in multi-operator based, accuracy is high and computational cost is high as well. In general, we have proposed a classification of context-based image retargeting techniques, providing a qualitative and different evaluation of the techniques in the subject, providing some qualitative evaluation criteria to evaluate the effectiveness on the context-based target technique, retargeting technique, the presentation of a hybrid technique as a future work, and developing the proposed framework in real-world problems can be done for future. Here are some of the references, and thank you so much for your attention.
So by resizing, you mean both scaling up the image and minimizing the image, right? And can we focus, for example, on a human and create not M by N and something special?
This is a formal representation of the image targeting, and these techniques are different based on the ideas they are using. So it really doesn't matter.
Thank you.
I have a question. Can you hear me?
Yes.
I am Eugene Tarkharenko from the Academy of Sciences, Armenia. And my question is, how can you measure the best set of your I think that you call you can call it like if you have one map, just for map for the Earth, and you have the second part of the same map. So how can you know which one is better? I'm sorry, your voice is so small.
didn't
Can somebody make it higher?
Could you repeat your question, please? I didn't understand you.
Okay. You must in your idea you must change the which mapping is the best as you have in your table. Did you?
Do you mean that I have to, as a result, I need to say which one is the best? Did I get it right?
I'm sorry. Somebody can make volume higher. I can't hear.
I'm saying that, did you mean that I have to have a comparison and as a result, I need to tell that which technique is the best?
No, I think that before starting this development, you must know which one you will count as best, and it is some criteria which is not usual.
I still don't understand the question.
Unfortunately, there's a misunderstanding of reporter. Maybe you will find a way to write. There's an email and
Okay.
formulate your question. I think it is the best way because unfortunately our time is short. So
Thank you.
once more, thank you very much.
Yeah. Thank you. Bye.
We'll be going to the next presentation. That is actually, that is our colleagues, Elizabeth Alaverdian, Surin Poğuzhan, Ivagan Poğuzhan. Counter to our solution and our school, and they do we swarm organizing in hostile.
Yeah. Hi, everyone. Thank you for being here, for taking your time. I will be very, very short. So this research is a rather conceptual introduction to our approach. The enhanced version with all the mathematical models well described will be published in the close future research papers. Swarms present collective intelligence that is believed to be more than the sum of individual intelligences together, because they exchange the information, they process, and they collaborate to make decision-making better. The mathematical models of these solutions are presented in recent publications of our team, Professor Suren and others. And these models were involved from simplest NPIL model to rotor-router and gossip broadcast models. This research mainly addresses the membership issues. Does this UAV belong to the swarm? Because we know very well that terrestrial soldiers may be masqueraded to legitimate wearing or masquerading and may destroy even the whole network and destroy the mission performance. It doesn't obey. Oh, yeah. And this is a research objective was to introduce a zero trust security architecture in self-organizing UAV swarms. What is zero trust? This is not a protocol and shouldn't be confused with zero knowledge proofs, but this is an approach. This is a philosophy. It replaced the slogan trust but verify. We change it to never trust and always verify approach. We should embed verifiable secret sharing and splitting to detect hostile outsiders. So this research mainly focuses to detect hostile outsiders to eliminate the risk of penetration to our network. Specifics of UAV swarm deployment concerns the scalability because we may replenish or we may remove some peers. It should be highly autonomic, self-organized, redundant. Communication and coordination should be well done. Challenges in UAV swarm technology are concerning with operation of swarms in dynamically changing environment, and the risks are infinite just because the domain is evolving and the risks also evolve parallel to this. The environment are dynamic and uncertain and maybe hostile, like adversarial networks. Swarm privacy issues is another concern because cybersecurity should be even reinforced with swarm introduction to stop hacking, intrusion, gaining surveillance, access the swarm data, and claiming for membership. You see that the outsiders may be penetrated, may try to penetrate to the network. Legitimate UAV may leave the swarm, and other legitimate UAV may join the swarm. And in this very scenario, all the public keys and session keys should be updated immediately because when we replenish or we reshape dynamically, reshape the swarms, session keys should be updated and private keys also should be refreshed. Traditional authentication to address the membership issues does not work here because in traditional approach, we have provers and verifiers, and we have a single node to verify everything. And this is the single point of failure. The verifier fails, the provers will remain unaddressed. So for swarms having no leader, many-to-many authentication techniques are required. These related works mainly address group authentication issues, and I wish to emphasize especially the last work from our neighbor. These solutions are mainly confidential, and these are the available solutions that we could discover. And especially it was interesting to us after 44 days of war. This last research mainly covered the authentication mechanism of Bayraktars. So we have deeply analyzed the solutions, the approaches, and came up with a new approach. And all this doesn't obey to my order. All these solutions, we found out that all these solutions are based on Shamir secret scheme, threshold scheme with T and N, T out of N scheme, and where the legitimacy of all participants are assumed. So all participants are believed to be legitimate. This doesn't work with swarms because we do not trust anything. We do not trust peers. We do not trust UAV swarms and swarm UAVs. And single point of failure is another issue with Shamir secret scheme. So we went far from this solution, this traditional approach, because this presents single point of failure. The secret is stored, split, and reconstructed in the single space. And on the other hand, problems with SSS getting a share, there is no way to verify that the share has not been corrupted. And the reconstruction even or succeeds or it fails. So this is not an acceptable solution. And then the adversarial shareholders will may even penetrate to this network and dictate own result. The solution to this problem is to introduce verifiable secret sharing, where we do not trust any shareholder, to introduce verifiable shares and to reconstruct the secret verifiable way. Our approach addresses security of UAV swarm data at rest, in transit, and in use. We know that encryption helps to protect data at rest and in transit, because everything is encrypted, channels are encrypted, end-to-end encryption works. But how about protecting data in use, when data is opened, decrypted, processed, and then encrypted again to store in a secure enclave? So this approach, traditional encryption, cannot help to protect the swarm data, and this is a very sensitive topic because it concerns national protection and national security. So we propose involving confidential computing. It doesn't obey. Okay. And asserting or claiming the swarm membership is done by introducing blockchain technology. We know that the blockchain works with Bitcoins and other Ethereums, and it presents a heavy proof of work. There should be some computation to discover a nonce that is unsigned integer, but it's a very, very huge work to reveal this integer. We adopted this blockchain, and we have eliminated several heavy computations that we replaced by secure multi-party computation based on graph isomorphism. The swarm is implemented based on Knödel graph to implement information full exchange, and the graph isomorphism is known to be a very light computation problem, but still resist to discovering attacks. We introduce digital and birth certificate for every UAV according to this methodology. And the blockchain gets incrementally updated when a UAV joins the group, and is updated when a UAV leaves the group. And peers claiming the membership perform a computation, and unsuccessful computation, if it fails, may lead to physically attacking the claimer. Two important points should be mentioned here to introduce verifiable secret splitting and sharing. We have to understand, and sometimes developers are confused with, we do not actually split the secret, but we compute something over those shares. And we do not share the secret itself, but we share the responsibility over this secret. And we suggest involving structures from modern algebra. And fortunately, our scientists from Yerevan State University, Movsisyan and others developed these theories, hyperidentities. Today morning, we were listening to Sergei Davidov's speech. So we closely cooperate with our scientists to introduce quasi-groups and other loops to introduce verifiable secret sharing. Quasi-group may be split into some shares. We compute something. We do not share these portions, but we do some computation, lightweight computation, still secure, and we encrypt the share and we distribute those shares. And when combined, we solve these 6 properties of the quasi-group to ensure the legitimacy of the claimer. Very doesn't react to my. I think what's happening. So with every cryptographic solution, we have to assess 2 main points: stability and efficiency. If the solution is not stable, it is rejected. If this is stable but hard working, it's also maybe rejected. So we have to find some balance between the stability of the proposed approach. Is based on stopping impersonation attacks. So it verifies the membership and belonging to the swarm. SSA and 256 or even higher with IS 256 is stored within secure computing environment in secure enclave within the hardware. And the efficiency is based on mainly involving logical operations, because graphs are implemented like binary matrices and quasi-groups as well. All the operations are logical, and the size even of the quasi-group that doesn't significantly change the algorithmic complexity. So we presented approaches for addressing the membership. So this is the conclusion list. So if you have any question, we are open to answer it. Thank you for the attention. Yeah. Yeah, this is our future. Mm-hmm. Yeah. Yes, thank you for your comment, because really we have discussion with physicists, and several type of radio channels solve this problem, and then at the very implementation stage we will consult with you as well, as an information theory specialist. Yeah, thank you. Yeah, sure. Because for very special information exchange, we proposed this approach to stop the encryption and to involve these radio channels to somehow connect the devices. But encryption works to introduce encrypted blockchain to recognize each other. At this point, we cannot avoid using encryption, but this is a lightweight encryption. AES, symmetric encryption involved within the hardware, because of this, we introduce tamper-proof hardware solution. This mainly goes to the hardware, no software computation, for not being hacked by the enemies. Thank you for your comments.
Hello, I'm Setrak from the Institute of Informatics and Automation Problems, and my topic also somehow touches UAVs, and it's called context knowledge-based decisions for battlefields. Sorry. Yeah, so this is basically the plan how I'm going to present a little bit of introduction, then how we see the battlefield and how we present it, and then I will give a conclusion. So starting with the introduction, there are a lot of aspects of battlefield. Here is how we see it and what the points we try to touch. Oh, sorry. First is to assume we have goals and we analyze the situation respectively. And secondly, we have some plans for a group of goals, and we are attempting to execute these plans to achieve the goals. And third, we can present these plans with strategies and particularly with some exact actions to achieve. And at the end, we need to evaluate the strategies and see if they are accurately attempting to achieve the goals or not. So how we approach this situation of battlefield as a RGT, it's an abbreviation from reproducible game trees, a combinatorial class of problems where problems can be brought with the following points. There are interacting actors which have identified types of actions to perform, and the situations there are specifically defined, and goals and the utilities for each of actors are also known, and actors by their actions transform the situation, and thus the solution of such problems can be presented as a reproducible game tree. So to interpret the battlefield in such a way, we can have the battling sides as the actors and the different actions they can apply to the situation. For example, movements or attacks or retreats, such actions can be considered as actions, and the goals for each side can be different, but the main goal is to destroy the enemy, and the units involved and in the battle can represent the battlefield situation. So for this, what we try to do, yeah, this is a video, it won't play, I think. We try to apply our achievements from our RGT class, and for this we have some already available results. Firstly, we have considered values of a different wide range of urgent problems, and it was shown that the kernel of these problems is unified, so that achievements for one of these problems can be applied to the others. So we mostly considered with chess, so that the next details I will bring for chess, but we assume these results can be also applied for the others. So what we did is we have a way to present knowledge. We call it a network of classifiers, how we present the knowledge here. And if we have the different levels of knowledge, this first level is called the nuclears. Then we have other knowledge pieces, which are compositions or which relate to each other, and this is how we present them and call them a network of classifiers. And We have three dimensions which are used here for presentation. These are P, have, and two types of relations between the classifiers. So for presentation of situations, we have, for example, for chess, we present this in the following way. Firstly, we detect the units available, and then we reconstruct the situation, particularly in the solvers themselves. They present some specific group of nuclear classifiers. For chess, there would be figure type, color, and its positions. This is sufficient for describing the chess. And for each problem, we approach in a similar way to try to reveal the attributes needed to the classifiers needed to be used for presenting the situation. So, and at the end, we have some algorithms for execution of plans and attempting to achieve goals. And as a result, these algorithms propose some actions to perform from the available list. And by applying these actions, we transform the situation in our programs, and with these new situations, the same algorithm is executed to propose the next actions. And this is this is the algorithm for execution of a goal, and this is called trajectories and zone techniques. The basic idea here is that to not consider the situation because it's huge. Sometimes it's hard to process the whole situation with brute force. We define some zones of attacks. Then we consider the possible actions that can be taken as countermeasures, and then combining them, we consider how the attacker can attack and how the defender can, opponent can take countermeasures, and at the end we can see if the result is achievable or not, and what is the best path or strategy to achieve the goal. And here are some results we had. We researched this approach with naval defense problem, intrusion protection in computer networks, and for chess, as I said. Now, in the following, we aim to apply these achievements to battlefield problem in the way we present it, and there are the following actions to be taken: knowledge revealing filtering, and acquisition by the solvers of this problem, our programs, then how we present them in the solvers and how we present the situations in the solvers, and thus we can apply our strategy execution algorithms. So firstly, what we did, we collected a data set of military units from UAV view, from top view, and we classified them grouped them into 8 classes, since actually we have limited data because this data is not widely accessible. We have short data, and we had to group them to have some way to, so for example, we don't have exactly different types of tanks. We have a group that classifies them as a tank. And similarly, we have 8 classes for different types of military units. And firstly, we had a model which classifies them with some acceptable accuracy. And at first step, with some basic, with talking with experts, we revealed some basic classification, not classification, target selection approach, which relies on some limited expert knowledge to choose one target from the available one from such a view. And I don't know if, yeah, in this video you can see how it behaves. It continually processes the result, and from this classification result, it reveals what are available on the petal field and chooses one of them according to this limited knowledge. Basically, this limited knowledge is quite simple. I can say bring one example. So if you are dealing with the UAV, the main goal is to try to get rid of your first opponent, for example, from air defense unit. This is the first step, and next we try to expand it with using some specific battlefield situation. This is a squad in a defense line. The goal for them is very limited. They have only they need to only to attempt to defend. And here is how we define the situation and the knowledge here in our software. We have nuclears. We revealed that there are three important metrics for coordinates, X, Y, and also height is also important here. The type of military units available there. As I said, we have classified them in group of 8 types, and site which defines if it's own or enemy unit. So as a next step, we define the basic classifiers, which are compositions, some type, and we define the actual units. And there are 4 defending side, the actions are quite limited also. They have to apply their first action to fire or to fight, kind of. The second one is all around defense, and the third one is, in some cases, we need to retreat. And the main goal is to defend the protected defending line, but there could appear also other types of goals. And with such goals, we have plans, which are combination of these plans. And similarly, as I said, by grouping these types of classifiers, we also construct the situations. In this case, here is the way we define them. We have X, Y, and Z, unit type and site, and the situation itself is defined by a group of these instances of a list of instances of such attributes, basic classifiers, let's say. So as a conclusion, we have defined a group of constructed a data set which defines a group of 8 classes of military units, and we have prepared a model which classifies them accordingly. Secondly, we have expert defined classifiers based on which we apply these algorithms, and the developed algorithms are selecting the target and trying to track them and follow and provide the way to go straightly to own them. And the second one, as a next step, we try to extract them, and we brought more knowledge, which is on in our RGT solvers. There's nuclear basic types of classifiers, goals, plans, and actions for each site. Situations were defined for battlefield, and according to this, the decision-making algorithms as described can be applied, which are knowledge-based and do not require full processing with brute force, but are knowledge-based and adequate to human solutions, and can be applied to get some good results for these battlefield situations. And as a next step, we are going to we have picked some exact situation from a real life situation with proper territory, with some exact positions, and we are trying to simulate them and see how it behaves in this exact situation. That's it. We actually rely on machine learning available solutions. Based on some research, we picked one model and we're executing this. And the main aspects we dealt with is that the model needs to be kind of high accuracy and lightweight to behave in small, low power, low performance, small devices, which is somehow expected to be set on a UAV to use. Um, It's a good question. Actually, probably in some points we might have difficulties. That the model accuracy now is not that high, and actually the main issue with this is that the data is quite limited. So probably we might have difficulties if the human is hidden in leaves and so. But the main way we try to solve this is to enhance the data. So we are going to grab more data with some exact situations which are appropriate to battlefield. So assuming people can hide or how to differentiate the fake target from the real ones. And if we expand the data, we assume this will give some good results.
Yeah, thank you. Good afternoon, ladies and gentlemen. First of all, I want to say that I have spent a lot of time writing my speech and now want to kindly ask you to let me read it from my papers. So we are going on an exciting adventure into the world of Armenian speech recognition. We are exploring how three important speech recognition models, deep speech, NVIDIA NeMo QuartzNet, and CSIT2023, perform with different Armenian speech corpus. But that's not all. We'll be also introduced a brand new speech corpus for Armenian speech recognition tasks. Also, that corpus can be used for another natural language processing tasks such as spoken language identification, speech to text, speech synthesis, and so on. So before we get into all the details of the comparison, let's first determine the problem and learn about special challenges that make Armenian speech recognition interesting, but also quite tough. Armenian is an ancient and rich language, which makes it a unique subject for ISA automatic speech recognition research. We should know that Armenian has some tricky language features that make it different from languages that are studied more often. First of all, there isn't sufficient freely available data to train an Armenian speech recognition system. Unlike widely spoken languages like Russian or English, Armenian has a limited pool of annotated speech resources. Also, Armenian is famous for its complex word forms. Understanding how verbs change, how nouns have different forms can be really hard for speech recognition systems. Armenian's historical and geographic diversity has given rise to dialectical variations. This diversity stems from the historical context. Armenia once spanned a much larger territory before the tragic events of the Armenian genocide. As a result, training ISR models to recognize these dialects accurately becomes a complex task. The Armenian language, like many others, also incorporates loanwords or foreign phrases. These borrowed words from other languages can confuse automatic speech recognition systems and requiring a careful way of recognizing them. Surprisingly, there are very few Armenian speech recognition systems, and this shortage holds back progress in technology and makes it harder for Armenian speakers to access these systems. To achieve the best result, it's critical to compare and evaluate performance. But in Armenian systems, the lack of standard benchmarks is a big problem. And the last one, there is the challenge of limited computational resources. There are not any supercomputers that are often open to the public in universities for training strong natural language processing models. In the quest to explore Armenian speech recognition, one of the foundational steps was the creation of the robust and diverse Armenian speech corpus. The corpus serves as the backbone of this research, enabling to evaluate automatic speech recognition models effectively. The initial part of the corpus was diligently generated from the free-to-use audiobooks. These audiobooks have a mix of Armenian and international poems, stories, and novels. This mix makes corpus richer and shows the different languages and cultures in Armenian speech. To improve the collection and make it better, the Armenian-speaking community came to the help. Using specially designed software, individuals donated their voices. The application involves advanced voice activity detection technology. This intelligent tool ensured that the recorded data was top-notch, free from any unwanted leading or trailing silence that can be problematic during system training. As a result of these efforts, the corpus now comprises an impressive 57 hours of annotated Armenian speech data, representing a wide spectrum of linguistic variations and cultural richness. Moving forward, we will see the statistics of the corpus. The slide not only covers the distribution of Armenian letters within the corpus, but also offers a deeper look into various aspects and characteristics of the dataset. In-depth information regarding audio samples and the dataset can be found in the table on the right. And also mention the ratio of male and female voices in the dataset. This gender distribution adds another layer of complexity for ISR models, as they must adapt to nuances of both male and female voices. As I strive to improve Armenian speech recognition, it is important to make use of valuable resources I found online. Here are highlighted two important datasets that have played significant role in this research. The first one is Flavors dataset, which is a multilingual dataset designed by Google and offers more than 4,000 audio samples for Armenian language, totally 14 and 6 hours. The second one is the corpus of Armenian question-answer dialogue designed by Chakmakjan and Dolatyan. It contains 23,000 samples and totally 8 and 5 hours of data. And also want to mention that during the processing of these datasets, carefully filter them to keep only the best and most relevant dataset. For example, Armenian question-answer dialogue corpus contains speech in Western Armenian, but for training, we removed that part. At the heart of efficient speech recognition lies the integration of two components, the language model and the acoustic model. Combining these models amplifies the ability to transcribe spoken language with remarkable accuracy. The acoustic model defines the relationship between a speech audio signal and the phonemes, and the language model defines the relationship between language words and their sequence in that language. Text data for language model training was scraped from Armenian news websites, including articles about lifestyle, music, culture, politics, and sport. To efficiently collect this wealth of text data, developed a small console application. In total, processed more than 1.8 million articles, encompassing an extensive range of topics and genres. The result of this is a corpus comprising normalized sentences, more than 9 and 5 million. For language model training used CanLM open source software toolkit, which is a natural language processing toolkit and used to build n-gram language models for NLP tasks like speech recognition, speech synthesis, and machine translation. Before we explore the outcomes, let's take a closer look at the essential building blocks of the neural network structure that supports the acoustic model. The first one is deep speech, developed by Baidu and implemented by Mozilla. The second one is QuartzNet of NVIDIA NeMo project, and the third one is C3Net. The last two models are extensions of well-known Jasper speech recognition model. Also, in this slide, we can see hyperparameter for training and also edit augmentation to dataset to increase the size and to achieving higher accuracy. A final dataset contains 28,000 samples, totally 34 hours. This slide contains information about the training environment and measurement units used to benchmark the models. And finally, we can see the final result of 3 speech recognition models. The second column mentions the model size in megabytes, and after that comes word error rate and character error rate units with and without using language model. For experiment to practical solutions, I want to say that develop a small Python library providing speech recognition solution for Armenian language. It is freely available in Python environment. And soon will be ready our web application, which will transcript audio speech from microphone and from large audio files. And that's all. Thank you.
Our project, or we are using NVIDIA as API?
Look, NVIDIA provides implementations of well-known speech recognition models. It developed a platform which calls NVIDIA Memo Toolkit. And that platform provides every tool for natural language processing tasks. And inside that framework, you can find the implementations of the models, speech recognition models. The only thing that I have done is using that models, making benchmarks and a bit modifying it for complex Armenian language.
And one more question. Is your model going to be more grammatically aimed or more everyday speech rate?
Look, for grammatical models, I must use additional neural network, which must do grammatical checking. And there are many famous models that can be adapted for Armenian language and trained on Armenian dataset. But right now, it only transcribes audio speech with lowercase and without marked letters. It contains only Armenian letters without additional marks, and all the text generated by the model is lowercase. But in this case, it is again very useful for such tasks in Armenian. And the accuracy of the web application will be very high. For example, the word error rate for CSIT2023 model was 12%, if I remember correct. And for our complex language, it is a very high achievement, very big achievement.
And the last one, your web application requires you to give it a sample of your speech, or it is out of box capable of understanding you?
Look, there are 2 ways to use our web application. The first way is to record an audio from microphone and send it to server for processing and wait for the transcription. And the second way is to upload a file, audio file, in any format, and application will transcribe and return the transcription of that audio file. Sorry. For Bonnet Chihamematum. Audio file, the processed audio file, gives us an input argument to our neural network, the CSIT2023 model. After that, CSIT2023 do speech recognition task. It means it converts audio signal into text and returns that text from server to user. Ну, այս մոդելը կոնկրետ 0.8% է ճշգրտությունը։ Ну, սխալ մուտ է ճշգրտությունը, այսինքն 100 բարից 8-ը սխալ է կանխատեսում։ 100 բարից 8-ը սխալ է կանխատեսում։ Բայց այդ բավականին բարձր արդյունք է։ 8%։ 8% սխալվում։ 8% սխալվում կա տալիս։ Հա, այսինքն 92% ճշգրտություն։ There is no perfect language model, as I know, in this world. And this model also is not perfect. By increasing the size of our data set, we can get more higher accuracy. It's possible. Yes, I have used transfer learning technique to train the model, and the base model which I used was English. And I used That's why I am using. That's why I am using additional language model combined with acoustic model to correct the prediction of acoustic model. And it is probabilistic model based on language, based on resources of that language. The 9 million lines I've collected from the news websites. This model uses this probabilistic structure to correct the final transcription. Yeah, I understand. Okay, thank you.
because of time, I skip that slide. For example, the way model, everyone says this is the problem in the world. The problem is like this, the best coming up, then you find right many. I think one of the first one was